Hello, welcome to lecture 6. Today I am going to talk about circle. I will continue from the last lecture 5, circle. So mainly I will discuss today area of sector and segment. So this is part 2 of 2 lectures. This is mathematics for class 10, chapter 12. I will mainly discuss exercises based on NCERT syllabus. My name is Sangam Baneja. My details are given below. So let us revisit what is pi. We have discussed this extensively in class 9. So I will go quickly this slide. So circumference of a circle is directly proportional to diameter of a circle where the constant of proportionality is pi. So what I mean to say is that circumference is this is a proportional to sign. The symbol for proportional to is proportional to d. So therefore circumference is pi times d. This is a proportionality constant, and d is twice of r, double the radius. So I can write as 2 pi r. Okay, these are the unit. What if it is in centimeter, same unit you use, and the circumference will be pi times whatever the unit you are using. So if r is half, circumference will be pi unit. Okay, 2 pi r is half, 2 will get cancelled, so it's pi unit. So here I have discussed this in extensively in class 9. So let us not please go to my class 9 lecture. That is, if you plot circumference, you take circles of different diameters and you make the plot the data for different diameter, you will see that it fits a linear relation, that is y is equal to mx plus c, and if you have taken very accurately, this data will fall on the line, but since you are doing experimentally, will make some error. So this r square tells you how much error. If the errors are more, this r square value will be small. If error is less, r square value will come to 1. So here I have defined what r square is. Please go through it. This is your data point yi minus this is your fit value, that is this line, divided by y minus this is your mean. So if you put all the values, you will for all the data and you sum it, you will get this r square. Okay, this in more detail you will discuss this in higher classes. So again here I have tried to say what a radian means. That is angle theta is 1 radian when this arc s is equal to the length of this radius. This both the length, this length and this length, when they are equal to s, then the angle subtended is 1 radian. This s, if you go to pi, this is pi and this is 2 pi, or pi is what, 180 degree. So if you go one full semicircle, you will have this s will go, it will be 3.14 times. So sometimes that's why you write pi is equal to 3.14, or you can approximate pi also 3.14 as 22 by 7. So here just freeze it and go through it what I have written here. That is pi is 3.14 times when s and r are both same. So this is 3.14 radian or 22.7. Okay, this pi. Now we'll discuss perimeter of a polygon. This we have also discussed elaborately in class 9 lecture, where we have found the circumference of a circle and the area of a circle. So here we will use trigonometry. In class 9 we use much more basic geometrical concept. So since now we know trigonometry, we can find this perimeter of a polygon. What do you mean by perimeter? Perimeter of a circle is circumference, and for perimeter here for this polygon is sum of all this length. Okay, so there are say 5 length, 1 2 3 4 5 times b, that is the perimeter. 5 times b is the perimeter. So how do you find this perimeter for a given distance from center to this corner and for a given length of this each side? So here, and I can divide this polygon into 5 triangles, and this is your angle is theta, this angle is theta by 2. So I can write sine theta by 2 is opposite by hypotenuse. Hypotenuse is r. Okay. So here I have written b by 2 is a opposite, and hypotenuse r I have written. So b is what side b is. I take the r this side. So and this 2 is also there. So when I take it from right hand side to left hand side, I will have b is equal to 2r sine theta by 2. So where length of chord b for a given r and theta. So for a given r and theta, you can know what is the length of b. Now as I said, perimeter polygon is n times b. That is here 5 times b, n is 5 here. So n times side. So that is side we have found out. Side of b is 2 r sine theta by 2. So n is this n, and then I can write this theta is nothing but 2 pi by n. So I can write 2 n r sine this 2 pi by n by 2. So I can, this 2 and this 2 will get cancelled. So the perimeter will be 2 times n times r times sine of pi by n. So perimeter of polygon, this is the formula of a polygon. And for a very large n, if this n is very large, this quantity will become very small. Okay, and we have seen in our trigonometric that sine of 0 or sine of very small number is very small, which we have seen from the sinusoidal curve for a very small value of theta. Sine of theta is theta. So here I use that idea. So if I use here pi by n, so n and n will get cancelled. So 2r and pi remains. So that is 2 pi r. So perimeter is circumference is 2 pi r. So if you make it very small, many these edges will become smaller and smaller, and then it will overlap on the circle. Here it is not overlapping, but here you see it is has come quite close. So if you make many more like this polygon with n tending to very large, it will be like a circle. So for r equal to half, the perimeter is, so if r is half, perimeter is pi unit of length. So similarly, area of a polygon, which we have also discussed in class 9, not using trigonometry but using basic idea. Again, I use the same figure, and I know area is if I know this polygon, so I can divide into many triangles, and sum of all this triangle, there are 5 triangles. So if I know the area of one triangle, I can just simply multiply by 5 and get the area of the polygon. So area of one triangle is half times base. If this is b, half time base into height, and height is, suppose if this is theta by 2, so this is your adjacent side by hypotenuse. So I write here. So since sine theta by 2 is opposite upon hypotenuse r, that opposite side is b by 2. So I can write that b by 2 is equal to r times sine theta by 2. Okay, because sine theta by 2 is b by 2 by r. So I can move the r here. So this r sine theta by 2. So just freeze it and go through it. It is very simple. You will understand. So now I do a trick. I know that sine of a plus b, which we have again done in our class 9. Okay, sine of a plus b is what? Sine a cos b plus cos a sine b. So here sine a cos b plus cos, both are same. So I can write twice here. Okay, so sine theta by 2 plus theta by 2, this is 1 theta. So I can write this sine theta by 2 times cos theta by 2 from here as sine of theta by 2 plus theta by 2 is theta. So I can write as sine theta by 2 times cos theta by 2 as sine theta by 2. Here I have written sine theta by 2. And this is r times r is r square. So area of the triangle is r square, this is r square times sine of theta, this 2 comes here, sine theta by 2. So n triangles area of polygon will be n, if n triangles are there, then n times r square by 2 sine of theta. Theta is this theta, and this theta will be 2 pi by n. So if you know only this r, then you can, and if you know how many sides, then you can find the area of a polygon. So from here again I extend what we have done to find the circumference of a circle. Here also I take many triangles, or this be many sides if I take, then this angle, if n is very large, then 2 pi by n will become, sine of 2 pi by n will become 2 pi by n. And if I write this sine of 2 pi by n as 2 pi by n, this n get cancelled. So and 2 will get cancelled, so I will get pi r square. So here for area of a circle, if n is very large, this will overlap and you will get a area of a circle. If r is 1, if the radius is 1, then if r is 1 here, the area is pi unit length square. To understand this further, here I have taken this polygon, n equal to 3, then 4, then 5, and as I increase this n, then you will see that the perimeter of the polygon and circumference will be equal. Okay, so here perimeter of a polygon is given like this. This is a formula, and here you see for r equal to half. So if I take r equal to half, 1 by 2, 2 get cancelled, n equal to 3 sine of pi by 3. Okay, and then sine of pi by 3, you see the trigonometric table, and I have shown you how to also write the table. So from trigonometric table, you get sine of pi by 3 is root of 3 by 2, and if you multiply this, you get 2.598. And for n equal to 4, again n equal to 4, r is half I have taken for this. I use this formula, I get this, and 2.8. So as n increases, number of sides increases, it will approach to the value of pi. Okay, so as I had earlier said, for r equal to half, that is 2 pi r. Okay, r is half, so 2 pi times half is pi. So this will approach to pi. And similarly, area of a polygon, okay, for r equal to, here I have taken half, but here if I take r equal to 1, the area of a circle becomes pi, because pi r square, r equal 1 means only pi remains. So here you see that when n I am increasing, n equal to 3, I have 1.29, and when n equal to 4, I get 2. So as I increase n, the area will go slowly tends towards pi. So as n tend to infinity, perimeter tends to pi unit for r equal to half, which we have shown here. And for as n tends to infinity, area tends to pi unit square, because it is area is in square, length square. So for r equal to 1. So r will have a unit of length such as millimeter, centimeter, inches. And perimeter in unit, area in unit square, and volume in unit cube. Okay. So here we have only discussed circumference and area. So suppose for sphere, it will be r cube, that is millimeter cube or centimeter cube. This is unit of length. Okay, now we discuss some examples before going to exercises. Find the area of a sector of a circle with radius 4 centimeter, this is 4 centimeter, and angle, this is 30. So this is a sector, this is a minor sector, and this big one, this white area is the major sector. So here they have asked find the area of this shaded region and also this white unshaded region, major sector. Okay, this is a minor sector, this is a major sector. So area of a minor sector is, this is the portion 30 degree divided by 360. Only this much fraction is been used by this circle. So 30 by 360 of pi r square. Pi r square is the area of the circle. So it is very simple. I will get, if you do this, I have substituted the value of pi as 3.14. Use calculator and you will find it is 4.19 centimeters square. So similarly, area of the major sector will be what? Pi r square minus this minor sector, or 330 by 360. And this also you can do it. So why 330? 360 minus this 30 is 330. Or you take find the area of the full circle and subtract this area of the minor sector. That will give you the major sector. There are various ways of solving one problem. Okay, now next example, find the area of segment AYB. This is the area of the segment AYB. What do you mean by segment? Segment means suppose you have a chord here A to B. The smaller portion is called the minor segment. So in sector, the area is from origin to the circumference. But here, if there is a chord, under this arc AYB is the minor, the small portion is the minor, and this full white region is the major segment. Okay, if the line chord is in the diameter, then minor segment and major segment are same. So it is asking here, find the area of the segment AYB shown in figure if the radius of the circle is 21 centimeters. This is the radius, and angle AOB is 120 degrees. So how do you find it? Area of minor segment, this segment, is area of this sector, which is from A, O, B, and this full arc. Or sometimes the area of a sector people write as OAYB. So here I have written area of sector OAYB minus this area of this triangle. Okay, will give me the area of the minor segment. So area of the sector we have found here how it is 120 divided by 360 times pi r square. R is given. Okay, so area of sector I can find. So here I have written area of minor sector is theta by pi r square. Okay, pi I have taken 22 by 7. Okay, this is 21 square. This is not 212, 21 square. This is a mistake here. So this is 462 centimeters square. So the area of a triangle is half of AB times OM. That is the height, half of base. And this is 120. So this angle will be 60. So I can always say that AM is nothing but R sine 60. R is your 21, 21 sine 60. But you have total AB will be 2 times R sine 60. Here I have written 2 times R sine 60. This is this half. And OM is nothing but this is cos of, this is R times cos of 60. Okay, so this in trigonometric class, you please go through my previous classes and see how I write all this. So how do you remember this? Suppose this angle is theta, so the opposite side will, and this is R. The projection of this R on opposite side, that is R times sine theta is this one. And if suppose this is theta and the projection of this R adjacent to it will be R cos theta. Okay, R times cos theta, this length will be R cos theta, this will be R sine theta. So you please go to my trigonometry class and where I have discussed this elaborately. Okay, so I now substitute here. Okay, this 2 get cancelled. 21 sine 60 is half. 21 times cos 60 is this. So you get this answer. So therefore area of the minor segment is, okay, this area 462 minus this one. So here I have written here. So please go through it and complete this one. Okay, now another example. In figure 12.15, two circular flower beds have been shown on two sides of a square lawn ABCD of side 56 meter. This is 56 meter square lawn, and there are two circular flower beds. If the center of each circular flower bed is the point of intersection O of the diagonals of the square lawn, so both this center of this circular circle and this center of the diagonals are same, are coinciding, find the sum of the area of the lawn and the flower beds. So total area, this shaded region and this total white region, what is the area of the lawn and the flower bed. So how do we find it? We find the area of this sector. Okay, if I know the radius, what is the radius? This is 56 meter. So this height is 28 meter, half of it, okay, here. And so this is 28 meter, this is 28 meter. Then you use the Pythagoras theorem to know what is the diagonal. So this diagonal OA will be square root of 28 square plus 28 square, that is 2 times 28 square. So square root of 28 square is 28, and 2 times this square root is square root 2. Just use Pythagoras theorem and find it out. So I know now the radius. So, and since we know this is a diagonal and since this is a square, so this diagonal will intersect perpendicularly, which we have seen in earlier classes. So this is 90 degree. So I use 90 degree by 360 degree. This is the area of a sector, that is ODC. Okay, this area or this is same. Here I have written area of sector OAB is equal to sector ODC, that is 90 by 360, because this is 90 degree. Then pi r square. So this is pi is 22 by 7, and r square is square root of 2 square is 2 and 28 square. So I get this. So this is, I have to add 2 times. Here I have this 1, 2, 3, 2. This is twice. So this area, I have got this area of this sector plus area of this sector is this. And area of triangle is half base into height. Base is 56 and the height is 28 meter. Half base into height. So if I add, there are 2 triangles. So I have to add this sector plus this sector plus this triangle plus this triangle. So when I add, I get. So there is another method. As I said, you can do whichever is convenient to you. So area of minor segment is area of minor sector minus area of triangle. This is the minor segment, this shaded region, and minor sector is ODCO. This is the minor sector. So which we have shown here, the area of minor sector is theta by 2 pi times pi r square. With this fraction, this ratio you have taken. And area of triangle, see the previous slide, or you just go before. I have shown for given r is r square half sine theta is the area of the triangle. So the area of the segment is this one which we have found out here, and area of the triangle is this which we have found here, 784. So the area of this segment is 448. So this 448 plus 56 square, that will give me, this is 56 square plus twice of 448 will give me. So this and this answer is same. So whichever is convenient to you, please use that method. Find the area of a shaded region in figure where ABCD is a square of, this is 14 centimeter. So that means this is half 7 centimeter and this radius will be 3.5 centimeter. So there are 4 circles of radius 3.5. So 14 square is the area of the square minus 4 times this circle, area of this circle. I will get 42 centimeter square. So just freeze it and go through it. Okay, now another example. Find the area of the shaded design in figure where ABCD is a square of side 10 centimeter. This side is 10 centimeter. And semicircle are drawn with each side of the square as diameter. So each side, this is a semicircle drawn and this is the diameter. So what is the area of this? So it is very easy. If I know what is the area of a square and if I know what is the area of this white region, then I subtract this white region from the area of the square, I get the area of the shaded region. So here I have shown area of square is 100 centimeter square, and since this is a semicircle, so if I take 2 of the semicircle, it becomes 1 circle. So area of this full region here, including this white here, excluding this one. So I have this area of a circle is 78.5. So if the area of this 1 and 3 will be 100 minus 78.5. So similarly, area of 1 and 4 will also be 21.5. So I get 21.5 into 2 is 43. So area of the shaded region will be 100 minus 43. That is 57 centimeter square. Okay. So you subtract all this 1, 2, 3, 4 region and you will get the area of the shaded region. Just pause it and go through it and try to understand. Now exercise 12.1. These are all very easy exercise, so I will only give you hint. I may not give all the steps, so please fill in the gaps. Exercise 4, the wheel of a car, and I will, the one which are very trivial, I will not do that. These are also very trivial which I am doing. But anyway, exercise 12.1, exercise 4, that is the wheel of a car are of diameter 80 centimeter each. How many complete revolution does each wheel make in 10 minutes when the car is traveling at a speed of 66 kilometers per hour? Okay. So here distance travel will be speed into time, because speed is distance travel per unit time. This time and this time will get cancelled. You will get the distance travel. So D is 66 km per hour. That is 60 minutes into 10 minutes. So it will travel 11 kilometers. And so circumference of the wheel are 2 pi times r. This 80 centimeter is the diameter. So 40 centimeter will be the radius. So that is approximately 0.4 meters. So because you have to use the same unit, so your d by c, that is total distance traveled by the circumference, will tell me how many revolution has taken. Okay, how many times this circumference has covered this distance d. So I know this is the distance, that is 11 kilo is 10 to the power 3. I have converted into meters. And this is your C is your 2 pi r. So here 2 into 22 44 and 7 I bring it up, and here it is 0.4. So if you do this, you will get 4375. Please pause it and do it yourself. Next exercise, tick the correct answer in the following and justify your choice. If the perimeter and the area of a circle are numerically equal, that is perimeter and the area, that is circumference, and that is 2 pi r is equal to pi r square. Here I have written 2 pi r is equal to pi r. Both are same. Then the radius of the circle is, here pi and pi get cancelled. So r and 1 r get cancelled. So r is equal to 2. So it is 2 units. Now exercise 12.2. Find the area of sectors of a circle with radius 6 centimeter. R is given, an angle is 60 degree. It's very simple here. 60 degree is nothing but pi by 3. So you just pause and see how I have done it. It is very simple. Find the area of quadrant of a circle whose circumference is 22 centimeter. Okay, so if the circumference is 22 centimeter, means 2 pi r is equal to 22 centimeter. So I can find r. R is equal to 22 by 2 pi. So 11 by pi. So you find what r is. And 1/4 of the circle area will be 1 quadrant. Okay, so whatever area of a circle you get with the radius, you take 1/4 of it, you will get the area of the quadrant. I am not going to do this. These are very simple. I am only giving you understanding how to go about doing it. Okay, now exercise 3. The length of a minute hand of a clock is 14 centimeter. Find the area swept by the minute hand in 5 minutes. So 5 minutes, how much angle it will go? We know from 15 minutes is from position 12 position to the position of 15 minutes is 90 degree. So if in 5 minutes it will be 1/3 of 90, that is 30 degree. So area swept will be 30 by 360 pi r square. So this is the answer. So these are all very simple problem, but I am doing it so that you get confidence that these are really simple. See how quickly one can do this problem. Okay, next problem. A chord of a circle of radius 10 centimeter. This is the radius is 10 centimeter. Subtends a right angle at the center. So this is a right angle. That's why I have drawn here a square. Right angle at the center. Find the area of the corresponding minor segment and the major segment. So now you know this is 90, this is, so what is minor segment? This is the minor segment. And what is a major segment? Major segment will be this full yellow, including this triangle area, the white will be the major segment. And what is a minor sector? Minor sector is the area, triangle, this triangle, and this small minor segment area will be the area of the minor sector. Okay, by now you should know what sector is. Sector is starts from origin, and segment is the area under this chord. Okay, either this is a minor segment and the area, this full area is the major segment. So minor segment is my area of the minor sector minus the area of this triangle is the area of the minor segment. So just go through it. It is very simple. So what is the area of minor segment? Minor segment is area of the minor sector. This is the minor sector. Okay, from here to here, this yellow triangle plus this yellow line minus the area of the triangle. So that will give me the area of the minor segment. So what is the area of minor segment? Also one can show that this is nothing but half of theta r square. So you are writing pi r square, no? So this is your 90 by 360 is 1 by 4. So here it is. So you can show that this is also very similar. Or you write here 90 degree by 360 times pi r square is same thing. Minus of half, I call this as base. And this is height, half base into height. I substitute these values and I will get this. So area of major segment is pi r square. This is the area of the circle minus the minor sector. This is the minor sector. This triangle plus this yellow region is the minor sector. And we have shown that minor sector area is 1 by 4 times pi r square. Here I have written here. And now so pi into r square. This is 10 into 10, 100. So 3.14 into 100, 314 into 3 by 4. This becomes, this is 3.14. Into 100 is 314, into 3 by 4 is this. So this is the area of the major sector. Okay. Now exercise 5. In a circle of radius 21 centimeter, an arc subtends an angle of 60 degree at the center. Find the length of the arc. So R into theta, that is R, that is 21 centimeter pi by 2. This is the length of the arc. Area of the sector will be half of here I have written half of theta r square. So here I have written half of pi by 3 r into r, that is this. And area of the segment formed by the corresponding chord. So similarly you do whatever we have done here for this third point also. Next exercise 6. A chord of a circle of radius 15 centimeter subtend an angle 60 degree at the center. Find the area of the corresponding minor and major segment of the circle. So here you see here, if this angle is 60 degree and this is 15 centimeter, so it is like if it is 60 degree is an isosceles triangle. Two sides are equal. If it is 60, then this also 60 plus 60. This angle will be same. So then area of equilateral triangle is nothing but, here you have written half of base into height, as I have shown earlier, a sine 60, and this is what it is, the area of the equilateral triangle. A square 6 sine 60 is root of 3 by 2. So if you subtract the area of this triangle from the minor sector, you will get the minor segment. So similarly, from the area of a circle, if you subtract the area of minor segment, you will get the major segment. So minor segment and major segment of a circle you have to find. So you can find. So I am not doing whole because I don't want to do spoon feeding. So you should able to do it yourself so that you will not forget. Now next exercise 7. A chord of a circle of radius 12 centimeter. This radius is to subtend an angle 120 at the center. Find the area of the corresponding segment of the circle. This is very similar. I will not do as the earlier one. Okay, next exercise. A horse is tied to a peg at one corner of a square shaped grass field of side 15 meter. This side is 15 meter by mean of 5 meter long rope. This is 5 meter only. So it can move only in this circle. So 5 meter. So R is 5. So the area of the powder field in which the horse can get is very simple. Okay, pi r square 1 by 4 times pi r square, where R is 5 meter. Okay, this will be the area, okay, of the quadrant of a circle. The circle is full, it is only 1/4 of it. So when you say quadrant of a circle means 1/4 of a circle. So this is easy to find. The increase in the grazing area of the rope were 10 meter long instead of 5 meter. Now instead of 5 meter you make 10 meter, so it can go from up to here. Okay, 10 meter long. So how much area it has increased? You find this area minus this area, this much area it has increased. Okay, so here I have written area of sector. You can also say area of sector is 1 by 4 pi r square. Okay, this is angle is pi by 2. So half of theta r square. Theta is pi by 2, half. So that become 4. So it's very simple. You practice, otherwise you will not remember. And here also I have said that this, say, radius is R1, here big one, and R2 is a small one. So this area is the extra area he gets. Now exercise 9. A brush is made with silver wire in the form of circle. Okay, some kind of a brush is made with a silver wire of a circle of diameter 35 mm. The diameter is 35 mm. The wire is also used in making 5 diameters. Okay, this is say 1 diameter, 1, 2, 3, 4, 5. Okay, 5 diameter, which divides the circle in 10 equal parts. Okay, so there will be 10 equal parts. This 5 and of course the other end 5 also, 10 equal parts. Find the total length of the silver wire required. So perimeter plus all this diameter. So how do you get it? 2 pi r. R is given to you, that is diameter by 2, 35 mm by 2. So 2 pi r you substitute here and 5 times this diameter 35 mm. So you get 285, okay, millimeter. And similarly the area, I'm not writing sometime unit, but you should take this unit, okay. R is in millimeter, diameter is in millimeter. Make all the unit same. And the area of each sector of the brush, then area of each sector is 36 degree because there are 10 of them. 360 divided by 10 is 36 degree. So each area is 36 degree by 360. R you know from here. You substitute and check in your book whether your answers are correct. Okay, next exercise. An umbrella has 8 ribs which are equally spaced here. So if you see from top, you can see that 1, 2, 3, 4, 5, 6, 7, 8 ribs are there, equally spaced. Assuming umbrella to be flat circle of radius 45 centimeter, the radius is 45 centimeter. Find the area between 2 consecutive ribs of umbrella. This is also very easy. Okay, that is, since 8 is 360 divided by 8 is 45, 45 degree divided by 360, so pi r square. So this is the area between the 2 consecutive ribs of the umbrella. Okay, now exercise 11. A car has 2 wipers which do not overlap. Each wiper has a blade of length 25 centimeters sweeping through an angle of 115. Find the total area cleaned at each sweep of the blade. So this is also very simple. That is, again I write 115 degree. This should be degree divided by 360 degree. So this theta by 360 degree pi r square, this is pi 22/7, and there are two wipers. So this is the area of the sector, and you just simplify it and you will get this answer. Next one, to warn a ship for underwater rock, a lighthouse spreads a red color light over a sector of 80 degree to a distance of 16.5 kilometers. So here also radius is given, distance is, this angle is given. So find the area of the sea over which the ships are warned. So the area of the sector is 80 degree by 360. Similar to this one, and you get a 189.97 kilometers square. So a round table cover has a 6 equal design. Okay, this is as shown in figure. If the radius of the cover is from the center point to here is 28 centimeter, find the cost of making the design at the rate of 0.35 rupees per centimeter square, and use square root 3 is 1.7. So here you have to find this each segment. 6 segments are there. So segment means area of the sector minus the area of the triangle. That is what 6 of them are there. Area of the sector minus the area of the triangle. Just pause it and go through it. This is 60 degree because 6 of them are there. 60 into 6 is 360 degrees. So 6 of them are there. This is pi r square minus of the sine 60 is root of 3 by 2. Root of 3 value is given here approximately, and you can simplify it and get this answer. So for this many centimeters square, 0.35 rupees per centimeter square. This centimeter square will get cancelled. So you will get rupees 162.68. Next problem 14. Tick the correct answer in the following. Area of the sector of angle P in degrees of a circle with radius r is, that is P by 360 into pi r square. This is 360. 720 divided by 2 is 360. So P by 360 by pi r square. So this is the correct answer. Others are not. 2 pi r is circumference. This is not a correct. This is your 2 pi r, again this is circum. So this also cannot be correct. So it should be area. Okay? Area of a sector. So it should be in r square. So either this or this. So this is not correct. So this has to be correct. Now exercise 12.3, find the area of shaded region. I will not go in detail each steps, but I will give you the hint so that you should be able to do it yourself. So find the area of the shaded region. If PQ is, this is PQ is 24 centimeter, PR is 7 centimeter, and O is the center of the circle. So here actually this diagram is not a correct representation. It should have been this red dash here, but even any point on this circle to this diameter, the angle will be 90. This also angle is 90. If some other length 24 and this also would have been 24, then also it is, because from any point of a circle to this diameter, this angle will always be 90 degree, as we have seen in class 9. Okay, so go through my class 9 lectures on circle. So if I know the area of this triangle and I know the area, half the area of this circle. So half the area of the circle minus this area of the triangle will be the area of shaded region. So that's what I have done. So diameter will be 25 centimeter because this is, you can use the Pythagoras theorem because this is a right angle triangle. So here is 25 centimeter because this angle is 90 degree. And area of triangle PQ is half of base. This is half of 7 centimeter is the base into height. Height is your 24. So area of triangle you know, and area of circle of the semicircle half of pi r square. So area of shaded region will be area of the semicircle minus this one, area of triangle. This is the answer. Okay, just go through it, check it. Okay, now exercise 2. Find the area of shaded region in figure. If the radii of two concentric circles with center at O are, small one is 7 centimeter and bigger radius is 14 centimeter respectively, and this angle subtended is 40 degree, then find the area. It's very simple. Find the area of the big sector minus the area of the small sector will give me area of the shaded region. So here 40, this is the area of the sector of the big one. R1 is 14 centimeter, R2 is 7 centimeter. So you substitute this value and you will get the answer. Now exercise 3, what is the area of the shaded region? So you find the area of the square and then find the area of this circle. Okay, this is semicircle, half circle and half circle, one full circle. So radius is 7 centimeters. So pi r square will be the area of this white region. And area of this will be 14 into 14. So 14 square minus this area of the circle, if you do, you will get the area of the shaded region. It's simple. And what is the area of this shaded region? There is a triangle here. It is 60, 60, 60, and area of this circle. Okay. So how do you find this area of a equilateral triangle? If it's 60 degrees given, which we have done several times earlier, and this is your 60 means this 300 degrees, 300 by 360 pi r square. So this is the area of the major sector plus area of this triangle. So you add it and you will get it. So substitute this value. A is 12 cm and see in your textbook whether you get correct answer. Exercise 5, this is also very simple. Okay, this is 4 centimeter. This is a circle of 2 centimeter. Radius is 1 centimeter. So now you have two circle of 2 centimeter. So you find the area of this circle plus one more circle, add them and subtract it from the area of the square. So you will get the area of the shaded region. Here is find the area of, in all this problem is to find the area of shaded region. So these are the shaded region. So you know the radius is 32 centimeters. So you know the area of the circle, you know the area of a triangle, you subtract it. So you will get the area of this design shaded region. Similarly, how do you find this one, area of this shaded region, this blue region? So this square is given of 14 centimeters. So I know that if this is 14 centimeter, area of circle will be, this radius will be 7 centimeter. So area of this circle will be pi r square, where r is 7. So now this area of this circle, it is only 1/4. So you have 1/4 here, 1/4 here, 1/4 and 1/4. So this is one full. So area of this white region, you know, is the area of the full circle. Then area of the square also, you know, is 14 centimeter into 14 centimeter. So you get some value minus the area of one circle. So this is the area of the blue region. So you should do it. It is very simple. I am not going to do it because it will take more time. In figure depicts a racing track. This is a racing track whose left and right ends are semicircular. These are semicircular. The distance between the two inner parallel line is 60 meter. From here to here is 60 meter and long. If the track is 10 meter wide, this track is 10 meter wide, they are each 106 meter long. So if the track is 10 meter wide, find distance around the track along its inner edge, this edge, and area of the track. So all these parameters are given to you. There is 60 meter between the inner track. From here to here 106 meters and this 10. So you know the inner, this is a semicircular. So radius will be 30 meter and this is 10, I know it. So 30 plus 10, this will be, the radius will be 40 meter. So you can know the half of this circumference will be this length and this half also. So area of this perimeter of this circle you now know, and you know the length also. So distance around the track, you know, this distance 106 plus this perimeter around the track along the inner edge. So inner edge will be 30, okay, pi. So the area of the track you can find, okay, you know, you can find the area of the outer track and you can find the area of the inner track. So area of outer track minus area of inner track will be this region. So that will be the area of the track. So you should be able to do it yourself. Exercise 9, what is the shaded area of this shaded region? Again, it is very easy to find it. This is 7 centimeter. So you know, if the radius is 7, then you know the area of this one. This radius will be 3.5. So pi r square for this shaded region. Then of course you know this is 90. So you can know the area of this segment. You add this segment, this segment, this segment. This is the total area of the shaded region. Now exercise 10, what is the area of this shaded region? This also can be found. This area of an equilateral triangle, this ABC is given, this area is given. So once the area is given, you know area of the triangle is half base into height. So this is, suppose this is your equilateral triangle. This is the base. This all, each side is say B. This is B by 2. And H also you can write in terms of B. This also. So once you know what B is, so half of that B will be the radius of this circle. So from there you can find the area of the sector. So you have find this area of sector, 3 times of that, and area of triangle is given here. Minus the 3 times of this area of sector will give you the area of this region. So you should do it. Okay. This is a hint I am giving you. B you can find from here. Exercise 11, find the area of the remaining portion of the handkerchief. Okay. These are the design. This is given 14 centimeter. So this is your radius will be 7 centimeter. So you find the area of each of this circle by taking 7 centimeter as a radius. So you have altogether 9 circle. So pi r square you do it. And since this is 14 into 3 will be the length of each side. So you get the square. So from this area of a square, you subtract this 9 circles. So that will give you the area of the remaining portion of the handkerchief. This is the white region, remaining portion. So this is exercise 11. Check your textbook. What is the answer and verify your answer. Here you have been given this quadrant. So, and this is also been told is 90 degrees. So you know what is the area of sector, and you know half base into is the area of a triangle. So area of this sector or this quadrant minus this triangle will give you the area of the shaded region. So here also it is very simple. You can find the radius, that is this, use Pythagoras theorem. Since this is a square 20 centimeter 20 centimeter, you can know this diagonal. Square root of this square plus this square is your diagonal. So once you know the diagonal r, and this is theta, so you can find the area of the sector, or you can find the area of the circle and divide by 4 is same thing. So once you know this quadrant area of this circle, 1/4 of this circle, you minus this area of the square, you will get the area of the shaded region. And similarly 16 is also very same. You have been told this is 90, so you find the area, you have to find the area of this shaded region, the design. So you find what is the area of this segment. Okay, I have told you how to find the segment. So first find the area of a sector, then minus the triangle, so you get one segment here. And from this side also you draw an arc and you can find this segment. So twice of area of sector minus area of triangle will give me the area of the design. Just pause it and go through it. And this is the end of my circle chapter, and see you in next lecture.